One other thing that's kind of cool to talk about for any of my people who might be pre-med or are excited about medicine, there are some cool clinical applications of this. So for instance, there's a lot of clinical research studies where your independent variable is some new drug treatment that some researchers came up with, and you're trying to test how well this improves some health outcome. And there are a couple additional clinical things that you might want to consider. The first is what we call a placebo. So a placebo is an inactive substance or treatment that cannot be distinguished from the actual treatment. So for instance, you might hear this called like a sugar pill or something like that. And what you do is you give this placebo to your control group. So the experimental group gets the brand new drug that you're testing, and the control group gets your placebo. And maybe pause and think about why is a placebo necessary? Why would you want to do that? So it could be that the mere act of swallowing a pill every day, keeping up this regimen, is the thing that actually is improving your health. Maybe it's just having this regularity is a positive benefit. So we want to make sure that the two groups, again, are equated on all things possible. So let's make sure that both groups are routinely, regularly taking some sort of, pill or whatnot, so that in itself cannot be a factor we consider. So as you can kind of see, this process, this research design process is super complicated, and a good design, involves a bunch of decisions. So perhaps in my previous schematic where we gave our experimental group an apple and our control group nothing, that might be a problem. Maybe we should have given our control group a placebo fruit. I don't know, something that they also ate every day, but wasn't as healthy or had the benefits of an apple. And that way it wasn't just a matter of eating something every day that led to these results. So there's a lot to consider. One thing about placebos though, you may have heard of like the placebo effect, that just, the act of knowing that you're taking something can kind of make you feel like it's working. We're going to get into what we call a double-blind kind of procedure. It's basically asking, like, should you know what you're taking? Should you know whether or not you have the placebo versus the actual experimental drug? Both, and there's kind of two questions here. The reason we call it double is that, do we want the patient to know whether or not they're taking the real thing or not? But also, do you think the researcher should know whether they're taking the real thing or not? So maybe it seems kind of obvious that the participant, if we want these results to be pure, the participant probably shouldn't know what they're taking. However, maybe the experimenter issue is a little bit more vague. So chances are, when you interact with people, if you know something about them, you might implicitly kind of interact with them differently. So maybe we know that if we're giving a patient a treatment pill, which we're kind of expecting might work, maybe we're going to be more warm or friendly or understanding or helpful to these individuals. Maybe we're going to expect these individuals that they're going to show less social anxiety. So we're going to read into it and we're going to see in our results that they have less social anxiety. That kind of thing. So you want to be completely blind, both groups, double blind. Both the experimenter and the participant shouldn't know what's happening. And that way you can unbiasedly look at the results. That's what we call a double-blind procedure. Also, just here's the meme. I'm going to randomly throw memes in because I think they're funny. Okay, one other kind of methodsy thing we're going to talk about is how to study over time. And this is something that my research lab actually looks into a little bit. We can study development in a couple different ways. So first is what we call cross-sectional. So this is when data are obtained simultaneously. It's like you take a point in time and you just take a cross-section of it and you get a bunch of different people from different ages at that one point in time. So you might have a group of really young people and then some adolescents and teenagers and older adults, that kind of thing. And you're just taking different people in each group, but at one time point. Or you might have a longitudinal study. So this is when you obtain data from the same group of people, but across multiple time points. So maybe you take the same person when they're a baby, when they're an adolescent, teenager, etc., which takes longer, but it allows you to kind of, limit, again, confounds as far as, other extraneous factors that might be leading to your results. And kind of best of both worlds-ish is what we call a mixed longitudinal study. So this is when we take data from a cross-section of participants over a shorter period of time. So maybe instead of studying an individual from birth to adulthood, which might, take 20 years or so, maybe we study, certain groups from 2 or 3 year periods. And if we take a bunch of different groups like that, we might be able to get a better idea of how development occurs and kind of limit most of our compounds by at least, spreading them out among different groups. So these are different ways you might study development. They each have their pros and cons though. So obviously the quickest and expensive thing that you can do is that cross-sectional. It's just one time point, you study a bunch of things. But there's a problem called a cohort effect. You've heard of cohorts before. Right now, if you're a first or second year, that year your group is your cohort. So it's kind of just a group of people that all share similar experiences. So if we're studying a cross-section and we're studying, for instance, let's say a group of baby boomers, of older adults, and a group of Gen Zers, or your teenagers, they've lived through vastly different things. So if we're trying to test, for instance, how an apple a day affects both groups, there is so much different between these two groups in life experience, in economy, in politics, and things they had to endure, that there's probably a lot that goes into that. It's what we call a cohort effect. So there's other things that might be present that only that particular age group really had to go through. With longitudinal studies, however, it kind of reduces those cohort effects because you have the same individual. So if it happens to them at like one time point, it's not really going to be, it's something that they themselves will always live with, and it's not going to affect them just in one particular time of their life. However, it's really expensive and time consuming. Again, if you're going to follow someone from birth until age 20, your study is going to take you 20 years, which is hard for someone to want to fund you to do, and it takes so long to actually do. You might have people kind of drop out because after 5 years they're like tired or bored or something. Mixed longitudinal tries to kind of get at that. So there are fewer cohort effects and it's kind of less expensive, but still has the factor that people might drop out over time, and still takes time and money to study the same people across a period of time. So pause, think about, how might we study the effects of time in testing our hypothesis that an apple a day keeps the doctor away? So for instance, maybe does it help more if you're younger versus older? Maybe you want to test the same individual over a period of time, and maybe it has more of an effect when you're still growing and developing than it does when you're an adult, that kind of thing.